watching Number channel.
In the previous class, we have already studied about natural numbers, whole numbers, integers and fractions. Equations like 3x plus 7 is equal to 0 have no solution in the system of integers or in the system of fractions. In order to find out the solution of such equation, we need to extend the number system to a new number system. This system is known as the system of rational numbers. We will study rational numbers, operations on rational numbers.
Introduction to numbers. A number is a mathematical object, word or symbol used for counting and measurement. Natural numbers. The counting numbers are called natural numbers. This collection is denoted by the letter n and is represented like this. These are some natural numbers on the number line. Whole numbers. All natural numbers together with the number 0 form the collection of whole numbers. This collection is denoted by the letter W and is represented like this. These are some whole numbers on the number line. Integers. All natural numbers, 0 and negative, of natural numbers form a collection of all integers. This collection is denoted by the letter Z and is represented like this. These are some integers on the number line. Rational numbers. A number of the form p upon q, where p and q are integers, and q is not equal to 0, is called a rational number. P is called the numerator, and q is called the denominator. For example, 1 upon 5, 3 upon 2, etc. are all rational numbers. However, we do not include numbers like 4 upon 0 or 7 upon 0, etc., where 0 is the denominator. Such extended numbers are called the system of rational numbers. As another example, 5 upon 6 is a rational number, in which 5 is the numerator and 6 is the denominator. Thus, rational number is a number of the form p upon q, where p and q are integers, and q is not equal to 0. Equivalent rational numbers. Let p upon q be a rational number, and m be any integer except 0 and 1. Then p upon q is equal to p times m upon q times m. For example, 5 upon 7 is same as 5 times 2 upon 7 times 2, that is 10 upon 14. So, 5 upon 7 and 10 upon 14 are equivalent rational numbers. In a similar manner, 2 upon 5 is equal to 4 upon 10, is equal to 6 upon 15, is equal to 8 upon 20. Such numbers are called equivalent rational numbers. Positive and negative rational numbers. If a and b are positive integers, then the rational numbers a upon b and minus a upon minus b are both positive, and the rational numbers minus a upon b and a upon minus b are both negative. Thus, 3 upon 7 minus 11 upon minus 5 are positive rational numbers, and minus 3 upon 5, 17 upon minus 9 are negative rational numbers. Standard form of a rational number. A rational number, p upon q, is said to be in the standard form if q is positive and the integers p and q have no common divisor other than 1. The HCF of 24 and 72 is 24. Dividing the numerator and denominator of 24 upon 72 by 24, we get 24 upon 72 is equivalent to 1 upon 3. Absolute value of a rational number. We are familiar with the absolute value of an integer. Absolute value is denoted by the symbol shown here. Absolute value of a positive number, that is, integer remains the same. For example, the absolute value of 3 upon 5 is equal to 3 upon 5. Absolute value of a negative integer is always positive. For example, absolute value of minus 1 upon 5 is equal to 1 upon 5. Absolute value of 0 is 0 itself. Thus, for any rational number x, we write modulus of x is equal to x. If x is greater than or equal to 0, is negative of x, if x is strictly less than 0. Rational numbers on a number line. Like integers, we can represent all rational numbers on the number line. All positive rational numbers are represented on the right side of 0, and all negative rational numbers are represented on the left side of 0. Consider the rational number 1 upon 2. Note that 1 upon 2 is a positive rational number. Thus, it must be placed on the right side of 0. Also, since 1 upon 2 is smaller than 1, so 1 upon 2 lies in the open interval 0 to 1. We can see that 1 upon 2 divides the interval into half. Thus, it exists at the midpoint of the open interval 0 to 1.
To find the rational number between two rational numbers, let the two rational numbers be a and b. So, the first rational number between a and b is a plus b divided by 2. The second rational number between a and a plus b divided by 2 is a plus half of a plus b divided by 2. Similarly, we can find another rational number between a and b. In this example, we will find the rational number between 1 and 2. Solution: rational number between 1 and 2 is 3 upon 2. Comparison of two rational numbers. There are two cases which can arise in the comparison of two rational numbers. Case 1. When the denominator are same. In this case, that rational number is greater than the other which has greater numerator. For example, if p upon q and r upon q are two rational numbers and p is greater than r, then p upon q is greater than r upon q. Case 2. When denominators are different, in this case, first we find the LCM of the two denominators, then compare the numerators of the two rational numbers. The number with greater numerator is greater. Here is an example. We need to compare 2 by 3 and 4 by 5. As the LCM of 3 and 5 is 15, we multiply 2 by 3 by 5. We get 10 by 15, and 4 by 5 by 3, we get 12 by 15. Now, as 12 is greater than 10, so we have 4 by 5 is greater than 2 by 3.
Rational numbers. Properties of rational numbers. We have already learned about rational numbers. What are they? Numbers of the form p upon q are known as rational numbers. There are certain conditions that p and q must follow. P and q must be integers. Q cannot be equal to 0. Properties of rational numbers. It has a numerator and a denominator. The numerator and denominator are integers. The denominator is not 0. All integers and fractions are rational numbers. 0 is a rational number. Rational numbers can be positive or negative. We are now going to look at more properties of rational numbers. We are going to see how they behave in different situations. There are mathematical words to describe these situations. The ones we will be discussing now are closure, commutativity, associativity, the role of 0, the role of 1, negatives, reciprocals, and distributivity. Are you alarmed looking at these words? Are your eyes open wide wondering how you're going to do all this in one shot? And do so much more mathematics for the rest of the year? Don't be. Though the words may sound unfamiliar, you actually know every single thing already. You just didn't know it was called that. It's really simple and you'll finish this in no time. Just stay alert and let's start. Properties of rational numbers. Closure. What does closure mean? Closure in the simplest forms means what kind of an answer you get when you add, subtract, multiply or divide two numbers of the same kind. If your answer is the same kind as the kind of numbers, then you say that the type of numbers are closed. Otherwise, you say they are not closed. What does closure mean? These explanations in mathematics always seem complicated, don't they? But the examples always make it so easy. So let's just talk about the real thing now, shall we? Whole numbers are numbers from 0 onwards. Let's check closure for whole numbers under addition. What happens when you add two whole numbers? 7 plus 14 is 21. The answer is a whole number. 6 plus 0 is equal to 6. The answer is a whole number. You can add any two whole numbers. The answer will always be a whole number. So the whole numbers are closed under addition. That just means when whole numbers are added, the answer is always a whole number. Let's check closure for whole numbers under subtraction. What happens when you subtract two whole numbers? 14 minus 12 is equal to 2. The answer is a whole number. 14 minus 18 is equal to minus 4. The answer is not a whole number. When you subtract one whole number from the other, the answer may not always be a whole number. So whole numbers are not closed under subtraction. Do you understand what closed and not closed means now? Let's check closure for whole numbers under multiplication. What happens when you multiply two whole numbers? 7 multiplied by 5 is equal to 35. The answer is a whole number. 7 multiplied by 0 is equal to 0. The answer is a whole number. When you multiply two whole numbers, the answer is always a whole number. So, the whole numbers are closed under multiplication. That just means when the whole numbers are multiplied, the answer is always a whole number. Let's check closure for whole numbers under division. What happens when you divide two whole numbers? 16 divided by 4 is equal to 4. The answer is a whole number. 16 divided by 5 is equal to 16 upon 5. The answer is not a whole number. When you divide one whole number by another, the answer may not always be a whole number. So, the whole numbers are not closed under division. That just means when the whole numbers are divided, the answer is not always a whole number. Closure for integers. Integers are like whole numbers, but they also include negative numbers. Let's check for closure under all four operations for integers now. Let's check closure for integers under addition. What happens when you add two integers? 7 plus minus 14 is equal to minus 7. The answer is an integer. Minus 6 plus 0 is equal to minus 6. The answer is an integer. You can add any two integers. The answer will always be an integer. So the integers are closed under addition. Let's check closure for integers under subtraction. What happens when you subtract two integers? 7 minus 14 is equal to 21. The answer is an integer. 0 minus 12 is equal to minus 12. The answer is an integer.
Properly in your home.
You can
Thank
subtract
you.
any two integers. The answer will always be an integer. So, the integers are closed under subtraction. Let's check closure for integers under multiplication. What happens when you multiply two integers? 7 multiplied by minus 4 is equal to minus 28. The answer is an integer. Minus 2 multiplied by minus 4 is equal to 8. The answer is an integer. You can multiply any two integers. The answer will always be an integer. So, the integers are closed under multiplication. Let's check closure for integers under division. What happens when you divide two integers? 16 divided by minus 4 is equal to minus 4. The answer is an integer. Minus 12 divided by 5 is equal to minus 12 upon 5. The answer is not an integer. When you divide one integer by another, the answer may not always be an integer. So, the integers are not closed under division.
Let's check closure under all four operations for rational numbers now. What happens when you add two rational numbers? 4 upon minus 9 plus 3 upon 4 is equal to minus 4 upon 9 plus 3 upon 4 is equal to minus 4 multiplied by 4 upon 9 multiplied by 4 plus 3 multiplied by 9 upon 4 multiplied by 9 is equal to minus 16 upon 36 plus 27 upon 36 is equal to minus 16 plus 27 upon 36 is equal to 11 upon 36. Minus 3 upon minus 5 plus 1 upon minus 2 is equal to 3 upon 5 plus minus 1 upon 2 is equal to 3 multiplied by 2 upon 5 multiplied by 2 plus minus 1 multiplied by 5 upon 2 multiplied by 5 is equal to 6 plus minus 5 upon 10 is equal to 1 upon 10. The answer is always a rational number, so rational numbers are closed under addition.
What about the difference of two rational numbers? 3 upon 4 minus 7 upon 8 is equal to 6 minus 7 upon 8 is equal to minus 1 upon 8, which is a rational number. 5 upon 6 minus 2 upon 3 is equal to 5 minus 4 upon 6 is equal to 1 upon 6, which is a rational number. 8 upon 4 minus 2 upon 5 is equal to 40 minus 8 upon 20 is equal to 32 upon 20, which is a rational number. The answer is always a rational number. So, rational numbers are closed under subtraction. What about the product of two rational numbers? The product of two rational numbers is the product of the numerators divided by the product of the denominators. A upon B multiplied by C upon D is equal to A multiplied by C upon B multiplied by D is equal to AC upon BD, where B is not equal to 0 and D is not equal to 0. As you can see, the product of two rational numbers is also a rational number. So, rational numbers are closed under multiplication. What about the division of two rational numbers? Division is the inverse of multiplication. Dividing means multiplication with reciprocal. A upon B divided by C upon D is equal to A upon B multiplied by D upon C, where B is not equal to 0 and D is not equal to 0. As you can see, division can be expressed as a multiplication. A upon B divided by C upon D is equal to A upon B multiplied by D upon C, where B is not equal to 0 and D is not equal to 0. Now, the tricky thing here is we know that B and D cannot be 0, but A and C can be 0. If A is 0, it doesn't matter. The answer will still be a rational number. If C is 0, then the answer will not be a rational number. So, the answer of a division of two rational numbers will not always give you a rational number. Hence, we can say that the rational numbers are not closed under division. Did you understand the closure property? Yes.
Thank you for watching நம்ம சேனல். இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா லைக் பண்ணுங்க, கமெண்ட் பண்ணுங்க, ஷேர் பண்ணுங்க. வீடியோ அடிக்கடி பார்க்கறதுக்காக இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு மறக்காம பக்கத்துல இருக்கக்கூடிய பெல்